Today we're going to be learning about proportions in triangles. There's 3 theorems that we're going over, and the first theorem is called the side splitter theorem. The side splitter theorem states that if a line is parallel to one side of a triangle and intersects the other 2 sides, then it divides those sides proportionally. So if we look at our diagram and we re-evaluate the description, it said if a line is parallel to one side of a triangle. So let's assume that these 2 sides are parallel. Remember, your parallel symbol looks like a little arrow on the line. That means if these 2 lines are parallel, trace over them in orange, then they divide the other 2 sides of the triangle. The 2 sides would be this side and this side, the sides we have not touched yet. So it divides the other 2 sides proportionally. I'm going to add some points in here. Let's say this is X. And if I write a statement, I'm going to say if RS, that would be this line here, is parallel to XY, that is this line here, then we have proportional sides, meaning segment XR and RQ is proportional to YF and SQ. Okay, I'm going to take a moment and highlight those small segments. So in the numerator, I identified the smaller segment, XR, and I compare this to the numerator of the second fraction, which is YS. In the denominator, I'm using the second segment, RQ, and I'm comparing it to SQ. So if you are using the side splitter theorem, you can break the triangle into smaller segments within the side. Let's go ahead and focus on the examples. So the first example, we have triangle ABC. It's this larger triangle here. You can see that we have the side splitter theorem that's being used because I have this line and this line that are parallel. I know they're parallel because of those little symbols. So now I can set up a proportion, and I'm going to highlight the segments. I'm going to do this segment compared to this segment. Those will be my numerators. And I'm going to do the top segments as my denominators on each side of the triangle. So I am going to do AE over EC, and I'm going to set this equal to BD over DC. The length of segment AE, I highlighted this in purple, that would be 10, divided by EC, highlighted in green, which is 5. And this is equal to my second purple segment, BD, which is 16, divided by my second green segment, DC, which is X. And now I can use cross multiplication, or the cross product property, and I can solve. So I have 10x is equal to 16 times 5, which is 80. Divide both sides by 10, and x is equal to 8. And if you want to check your work, you can always substitute this value back into your proportion and make sure that it comes out to be true. Number 2 is a bit more challenging because now we are solving for a variable that includes an expression. Oops. But we approach this the same way. So first we identify that we have 2 parallel segments, so we can use the side splitter theorem, meaning we can compare the smaller segments or the base segments to the upper segments. I'm going to set up my proportion as PK divided by KM, and I'm going to set this equal to my proportion of NL, or my ratio of NL over LM. So I have both of my purple highlighted segments in my numerator and my green highlighted segments in my denominator. So just notice how I always keep my proportions consistent. I like to use color so I can clearly see what I'm working with, but you guys can solve that or approach this however you want. Just make sure you are consistent with the location of your variables. Okay, PK is represented with the expression of x plus 1. KM is represented with 12. NL is represented as x, and LM is 9. When we use the cross product property, we have 9 times x plus 1 is equal to 12x. I'm going to distribute my value of 9, giving me 9x plus 9 is equal to 12x. I am going to subtract 9x from both sides. 9 is equal to 3x. And I'm going to divide both sides by 3. X is equal to 3. If you want to check your work, you substitute this back into the proportion and you make sure it comes out to be true. Okay, number 3. So for number 3, we are using the side splitter theorem. We're going to solve for x, and then we need to use the fact that we have 2 triangles and we need to solve for y. So before we solve for y, let's just take a look at what we're dealing with. We have 2 parallel lines indicated with my parallel marks. Therefore, I can use the side splitter theorem. I'm going to highlight my base sections and my upper sections, just like I have been doing. I'm going to set up a proportion of ON over NM, and I'm going to set this equal to PQ over QM. ON and PQ are highlighted in purple, NM and QM are highlighted in green. When I substitute my values in, I have 10 over 20 is equal to x over 14. Cross product property, and I have 140 is equal to 20x. Divide both sides by 20, and x is equal to 7. Now I'm going to come back over to my triangle. I'm going to mark that x equals 7, and I'm going to highlight a couple of things. So I'm going to switch this, and I'm going to highlight the smaller triangle right here. I'm going to highlight that in green, and I'm going to highlight my larger triangle in purple. So if we can all focus on the fact that now we're looking at 2 separate triangles in order to solve for y. So when you're solving for a missing side length in a triangle, then you just want to use one side length that you have, and you want to set up a proportion to solve for the missing side length. So in just the green triangle, let's set up a proportion of, let's do NM. So we're going to do this side of the green triangle, and we'll set that proportion up to the total length of the purple triangle. Of course, we need to add 20 plus 10 to get this total length, which is 30. So we're going to set a proportion up using 20 and 30, and then we're also going to use 19 and y. So let me set my proportion up of NM, actually let's start with M. Let's do MN divided by MO. And let's set this up to NQ divided by OP. So in this figure, we're going to be using MN as our smaller green triangle and MOOP as our larger triangle. When I fill in the values, I'm going to have 20 divided by 30 is equal to 19 divided by Y. This is going to give me 20Y is equal to 30 times 19, which is 570. Divide both sides by 20, and Y is equal to 28.5. So this problem definitely was a little bit of a longer problem. We solved for two missing sides using two different processes. So make sure you clearly understand what we were doing on both of these. And next we're going to move on to a new theorem. The next theorem is called the corollary of the side splitter theorem. So this says that if three parallel lines intersect two transversals, then the segments intercepted on the transversals are proportional. Here's our three parallel lines in our diagram. I'm going to label the segments. In this diagram, if we know let me label the lines A, B, and C. If we know that A is parallel to B, which is parallel to C, then we know that our segments are also proportional. And when I'm talking about segments, let's use our purple and green highlighter. We have AB and WX. I have BC and XY. So I can say that segment AB over BC is equal to the ratio of WX over XY. Both my numerators are my purple highlighted section. Both of my denominators are my green highlighted section. If we look at the first example, I know that I can set up a proportion of these two segments compared to these two segments. Just like I usually do, I'm going to start with putting my purple segment in the numerator. So I'm going to set up a proportion of x over 24 equals 12 over 36. And you could flip these, like x and 12 could be your denominator and 24 and 36 could be your numerator. You'll end up with the same answer. Just make sure, again, you always stay consistent. That's the biggest thing. We end up with 36x is equal to 288. When you divide both sides by 36, x is equal to 8. At this point in the notes, we've done a lot of examples with proportions and solving. So I would like you all to try this next problem by yourself. You do have to find a few missing side lengths. I'm going to highlight where you have to find. You need to find this side of campsite A, so I'm going to label that X. And you need to find this side of campsite C, so I'm going to label that as Y. I'm going to give you a hint. You only set a proportion up with 4 values, so you're going to have to do 2 separate proportions to solve for both A and C, which I labeled as variables X and Y. Now please press pause on your video. Please try to solve for these missing variables, and then come back and check my answer. The last theorem is the triangle angle bisector theorem. This theorem states that if a ray bisects an angle of a triangle, then it divides the opposite side into segments that are proportional to the other sides of the triangle. If we look at this diagram and I label some points, if we know that AD is the bisector, that means it's dividing this angle into congruent angles. We can say AD, ray AD bisects angle CAB. That's this angle here. If that happens, then we can say there's a proportion, which is CD over DB is equal to over B. So I'm going to highlight here to illustrate. We have CD and we have CA. We have DB and we have BA. So in this case, I put my green highlighted segments in my numerators and my purple highlighted segments in my denominators. I could have done that the opposite way, but we just set a proportion up of the sides of the triangle. And you might need to reread this theorem a couple of times to make sure it makes sense. But I will go into more depth with the theorem as I go over this next example. So we're going to use the triangle angle bisector theorem to write our proportion, and I'm going to highlight the sides. This triangle is going to be in my numerator. This triangle will be the denominator. Now, a bisector, angle bisector, intersects a side. That's going to create these two segments that are proportional to these two segments. So when I set up my proportion using the triangle angle bisector theorem, I'm going to set up a proportion of segment AD over DC is equal to BA over BC. So again, I put the green highlighted segments in my numerator. And both green highlighted segments are on the same side of the triangle. My purple highlighted segments are in the denominator, which are, again, on the same side of the triangle. I fill in my proportion, and I have 3.5 over x is equal to 5 over 12. Cross multiply, and I have 5x is equal to 42. And when I divide both sides by 5, my final answer is x is equal to 8.4. And if you want to check your answer, you can take this value and substitute it back into your original proportion and make sure it comes out to be true.